I don't want to say it's the industry, it's what everybody thinks they'll go to when it's fully built. So right now it's still modeling, I guess. Actually, there's one facility that is built in. It's just you have to be doing full-scale manufacturing to require a facility of that size. So you need a product that really is high volume. So utilities here, and then downstream, labor is a big cost, but additionally consumables. And that one was the one that kind of snuck up on us. And the reason that the consumables, I feel like, snuck up on us, or we didn't realize this, is when we were doing this, we were thinking removing and simplifying. Chromatography resins cost us so much in the lab, but you don't think about the fact that they're completely reusable. Filters are cheaper for us in the lab, but if you're producing 100 batches a year, you're throwing those away every time. And so they're a consumable for them. Whereas you may use the same resin, the resin technology is improving so much that you may be able to use the same resin for all 95 batches. So it's going to take your consumable cost and drive them in the other direction, even though it requires specialty equipment and things like that to even run chromatography. So it depends on what you mean by simplifying. It's kind of where we ended up realizing on this. So here's just the raw numbers, and you can see labor and utilities upstream. I mean, you can imagine planting plants and keeping lights on and watering. It makes sense that that's where your costs are. And then consumables, labor are really where your costs are in the downstream. But let's get to the what everybody wants to know, or what we really wanted to know, the cost of goods per milligram. And what we looked at was at a 20 kilo scale, we're looking at about 11 cents cost of goods and about 32 cents per dose, because we're looking at a 3 milligram dose. Now, we achieved this less than $1 per dose, but what we don't have here, what we've manufactured is API, the active pharmaceutical ingredient. What we don't have is a drug product, or one that is going to people. So there's going to be additional costs in applicators or formulation or things like that. So this 32 cents per dose is great. It just doesn't leave us tons of room. So it's a great starting point. So we may even want to go back and look at, we've optimized for efficiency and purity and recovery, but now we may want to go back and look at that model again and see if we can optimize, maintain those recoveries, maintain those the purity levels, and see if we can trade things in and out and how it could impact our total costs. Specifically things that we like consumables. Because right now there's very few, we can move plant protein expression systems that maybe increase our yields, and that would drive down your total number of plants that you need, and then in turn drive down your utilities and things. But it's very difficult to, there's not much in the process that you can modify to change your upstream costs. So, basically I guess I looked at the conclusions there, didn't I? Yes. The process may be able to be optimized further, which is what I was just discussing. The development of Griffithson is moving forward. We've used the process at scale. We've produced quantities of Griffithson for a clinical trial. We've made drug substance that's phase 1 compliant using the process. We haven't made kilos of the product that's not needed at this moment for phase 1, but we have made 100-gram quantities of it. And what we need to do is take that manufacturing data and put it back into our economic modeling and see how the assumptions that we use there, what kind of, if the assumptions that we made actually, we're going to just test them and see if they would experimentally turn out. And so, yeah, I think this right now we're just at a point where we have a system that is good enough for the moment, but may need to be improved upon as long as our product still continues to progress through development. So we made significant progress, and we have the tools now to actually understand it better. So, let's see. I'm gonna stop here, I guess. It's 1 o'clock, and take any questions.
So how do those costs compare to traditional farming? I mean, I have no idea. I'm just kind of curious.
So,
Are there any other?
there's a high degree of variability. Well, so there's a high degree of variability depending on which product. Your antibodies are much more costly than this for most of them. That's generally most of your protein products that they're making for big pharma, but I don't know that I would even try to get into the concept that the plant expression system is that much cheaper, because the more we're into it, the more that I see that there's a lot of similarities to it. As in the bioprocessing use is you're filtering, you're using chromatography, you still have to have quality control and quality assurance. Like, the only thing different is your upstream, but their upstream cost is really going to be similar to ours, because they have to maintain temperature and oxygen, nitrogen content, and CO2 content on their cultures for their fermenters or bioreactors. And so their bank cost is probably going to be utilities there too.
Sure.
And so it's all,
I'm surprised at those numbers.
it all is going to end up looking very similar. Now, Glyphosate was isolated from red algae, and it's no surprise that it expresses well in the plant systems. It has had some issues expressing in E. coli, forming inclusion bodies and things like that, and some difficulties at achieving good numbers, usable yields. And so plants may be a good place for a select group of products that need a little more help in their folding than maybe they get in an E. coli system, but they're not requiring a full mammalian cell expression system. So the plants are moving a long ways as far as matching glycosylation patterns and things like that too, as far as with like antibodies and things like that. There's specific human glycosylation patterns, and they're making transgenic plants to produce those similar patterns, but it is not perfect yet. It's really close. And so, but the CHO cell industry, or the big biopharma industry has had a lot of years practicing this already. So I don't know about competing with them at their own game kind of thing. I think you're looking at more niche manufacturing here than you are, I want to produce the same thing, biobetters or biosimilars or something like that. Maybe you could do certain, it's going to be very product specific, I guess is the best way I could say. You're going to want to run a techno-economic analysis on their process and your process and see if you have a viable pathway. I think that's when it comes to plant expression, it's all going to be about how much yield you can get out and how much you're having to deal with. If you can achieve expression that's a lot higher than theirs, then you might actually have something that you can manage. But if you're expressing equal or lower, then because the costs I think are going to end up very comparable, because there are in a lot of other places that you just can't. You got to keep the lights on. You got to run quality checks on your product. I mean, there's just so many costs that are not in growing the cells or growing the plants. And that's where your biggest difference between the two is going to be at.
So you mentioned the melting temperature
Mhm.
of Griffiths. Do you know the temperature at which it denatures? And I asked because some of the processes we're looking at to incorporate your product, are either cell-based or we're trying to do low temperature, for instance, 3D printing with it is very exciting to us. But what range is?
As far as temperature goes,
Yeah, so like what temperature would Griffiths' functional activity or denaturation occur?
I think it's pretty close to the melting temperature from what I've done.
Okay.
But the way I've done that, so the way we've done that is thermal shift assays with mannose. So mannose is its binding partner, and you can put mannose in with Griffiths and then ramp the temperature, and then you add a hydrophobic dye in with that at the same time, and then the see how it interacts with mannose, and that binding to the mannose pushes the melting temperature even higher to like 86 degrees at that point in time.
So you have a dye bound to Griffiths or Griffiths competing with the dye?
Griffiths bound to mannose, but the dye will bind to Griffiths as soon as it's unfolded.
Okay.
And so, because it binds to the hydrophobic core of most of your proteins, and Griffiths does have a fairly hydrophobic core. And it looks like that in that assay, Griffiths is still binding to mannose even at like 78 degrees.
Okay, that's great news.
But it's not a perfect assay for really exactly what you're asking. But I think you could modify it potentially.
Also, did you say where you're outsourcing all this? I mean, I know you're growing some of this in the CTR, right? And in all these shelf-like rooms, but where all this is
Kentucky Bioprocessing is
still?
who has done a lot of our growth. The modeling is done based on another facility. I did the pilot scale manufacturing at Kentucky Bioprocessing. That was a long time ago when it was actually not owned by the company that's owned by now, and they let me go in the facility and run the pilot. But now you have to have your visitor's badge, and you can't. That's not gonna happen.
So you guys are looking at a different company to do this?
No, the modeling was done at a larger scale facility that could manufacture 20 kilos in it annually. I don't know that KVP has the capacity to do that. So that's the reason we looked at a different facility. For our current clinical manufacturing, KVP is the only group we're looking at. And nobody else probably is aware. So Kentucky Bioprocessing is small. Well, I don't know if I'd even call them small. They're about 40. There's about 40 employees. They're in Western Kentucky, Owensboro, Kentucky, and they are a plant protein manufacturing contract manufacturing organization. I guess they're one of the largest biotechs in Kentucky, really. Not maybe fifth. Third, fourth, because you have Lexington that has Beer Brewer that has probably one that makes the horse feed as well. I don't remember the name off the top of my head. But yeah, they're probably in the top 5 of size companies in Kentucky if you ever wanted to look for a place for a job. They're owned by Reynolds International now. So, all right. Thank you all.
Yeah, thank you.